Welcome to this explainer. We're diving straight into a totally paradigm-shifting framework today that is going to completely change how you understand light, color, and honestly, reality itself. Forget what you thought you knew about why an apple is red or why glass is clear, because we're looking at some incredible ideas drawn straight from the Relational Action Framework, or RAF for short. So, let's start with the most foundational question. What actually is color? We're all taught in standard textbook optics that color is just incident light bouncing off surfaces, right? Like white light hits a leaf, it absorbs everything but green, and green bounces back to your eye. But what if that's completely backwards? What if color is actually a structural output generated by the matter itself?
Which brings us to our first main section, the illusion of color.
Now, standard optics tells us a material just passively absorbs or reflects wavelengths. It's essentially treated as surface-level bookkeeping of existing photons. But the RF lens asks a way deeper question. Why does a material's internal geometry even permit that specific interaction in the first place? RF defines color as a closure compatibility. Think of it like a lock and a key. Color is just what the internal structure of a thing allows light to become when they perfectly meet. So it's not a passive bounce, it's a highly active negotiation.
This completely reimagines even the extremes, like black and white. Standard physics says black is just the absorption of all colors, an absence of light, and white is the reflection of all colors. Well, in RF, black isn't just an absence, it's a broad closure sink. It actively absorbs and forces incoming light to resolve internally. And white? White is highly active, a structural rejection that gives you a multi-mode scattering return.
Moving on to the next part, let's look at reimagining transparency and glass.
If color is this active interaction between light and structural geometry, what's happening when we look through clear glass? In RAF terms, transparency is defined as selective non-resolution. It isn't just nothing happening. Think of it as a VIP hall pass. The material is physically there, obviously, but its internal geometry allows light to pass with minimal closure conflict. It's permission without resolution.
And this explains prisms beautifully. Standard optics claims a prism just bends white light to split it into a rainbow. But RAF says a prism does not create colors out of nowhere. Actually, it's mapping out the material's wavelength-dependent relational pathways. It takes the invisible structural pathways of the glass and renders them completely visible.
Okay, this next section is where things get wild, when sound becomes light. To really shatter the whole bouncing light myth, we have to look at empirical proof where light is generated without any incoming visible photons. If we map this out, we have Class A, your standard light in, light out. We have Class C, where photons change modes, but the absolute magic happens in Class B, where non-photon energy literally converts into photons.
Look at these Class B phenomena. This is where it gets crazy. You've got an electric current in an OLED making light, chemical reactions in glow sticks, mechnoluminescence, where literally snapping a piece of adhesive tape in the dark creates a flash, or sonoluminescence, where acoustic sound waves collapse tiny bubbles in water to generate brilliant flashes. These prove that material structures can take entirely non-light inputs, like mechanical stress, chemical reactions, acoustic collapse, or electric currents, and convert them directly into photon outputs.
And that brings us to this incredible quote. It empirically proves a core concept. Radiative color and spectrum are not merely the result of incident light bouncing off surfaces. Light is fundamentally generated by a material transition. It's a signature of how matter resolves energy through its internal structure.
So how do we make sense of all this? That brings us to the universal rule of radiation. Now, standard physics has individual super-fragmented mathematical explanations for all those things. OLEDs are device physics, glow sticks are chemistry, and so on. But what makes RAF so different is the new predictive lens it provides. Rather than treating each type of light generation as a fragmented category, RAF highlights a single unifying pattern. Radiation is a closure resolution channel. It all boils down to this master equation. The unifying pattern is simply disturbance plus closure pathway equals radiation. Whether that disturbance is an electric field, a chemical reaction, or mechanical stress, when you combine it with a material's internal closure pathway, you get radiation. A photon isn't just a traveling bead, it's the physical signature of a system resolving a constraint.
And that sets the stage perfectly for our final section, the quantum geometry prediction.
Because any good scientific framework doesn't just explain the past, it predicts the future. Most importantly, this framework leads to a specific, testable prediction that differs drastically from traditional textbook optics. It predicts that optical appearance should be tunable by altering a material's relational or quantum geometry, even if its ordinary energy dispersion is kept approximately fixed. This means you could theoretically change a material's color or transparency, not by altering its chemical composition, but by changing the wave function texture or structural relationships within the material itself.
And no, this isn't just theory. Emerging 2025 quantum geometry research is already beginning to support this exact direction. They are finding that you can alter optical conductivity, reflectance, and color by changing geometry alone. Imagine changing the color of a car or making a solid wall clear just by rearranging the invisible architectural relationships, that wave function texture. It's a massive proof of concept for the RAF lens. So if color is truly an active structural signature, and if a material's internal pathways can magically transform sound and stress into light, it leaves us with one pretty mind-blowing question. If reality's underlying geometry dictates color, what hidden, unseen spectrums are we just waiting to unlock? Something to chew on. Thank you so much for joining me on this explainer. Stay curious, and I'll see you next time.